Hello dear students, welcome back to my science class. Today I am going to continue with the chapter electric current and its effects. In our previous classes, we already have discussed about symbol of electric components. We have learned about how to draw electric circuit diagram. We also have learned about heating effect of electric current. Also, we have discussed about magnetic effect of electric current. We were discussing how we can create our own electromagnet. Like we have discussed in activity 14.17, where we have taken a compass needle and we have taken a tray of matchbox and wrapped around a wire. With the wire, we have connected one bulb and switch, of course, and battery. While doing this, whenever electric current will flow through the circuit, we will notice magnetic deflection. The magnetic needle will show deflection without presence of any other influence of magnet. That means the magnetic field generated while electric current is flowing through the circuit. Taking concept of this, we can prepare our own electromagnet like this. We have taken iron nail, wrap around wire, and then we have make a closed circuit. Whenever the circuit is closed, we can see that the iron nail achieve the power of magnetism and attracting the pins. Now here we have to take care of one thing. What is that? We have to take care while doing this experiment. Remember not to switch on the current for more than a few seconds at a time. The electromagnet weakens the cell quickly if left connected. If you again look at this experiment, you will see that there is free flow of electric current. So electric current will flow freely through this circuit and cell will be quickly used up. So, we can switch on this circuit only for few seconds to do the experiment. While you can see in the previous experiment where we have checked the magnetic effect of electric current, we have kept one bulb also in this. If the bulb was not there in the circuit, then also we will be able to see the magnetic effect of electric current. But the filament of the bulb adds some resistance to the flow of electric current. So it will not be used up so quickly as in the next case. So while making that electromagnet, we have to be careful that we are not keep it on position, on switch for a longer time. Now actually we are going to enter in today's lesson, that is electric bell, application of electromagnet. We are quite familiar with an electric bell. It has an electromagnet in it. Already we have discussed that electromagnet is a temporary magnet. It only shows power of magnetism whenever it is attached, connected to an electric circuit. Figure 14.20 shows the circuit of an electric bell. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. The iron strip with the hammer at the end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows to the coil, which becomes an electromagnet. So here we have taken the soft iron piece which is wrapped around by coil of wire. Okay. And now whenever it is a closed circuit, at that time electric current flows to the circuit. Right? So whenever this achieve the power of electromagnetism, it will attract this iron, soft iron bar, and it will be attracted towards it. Hence this hammer will hit the gong and bell will ring. But once it is attracted to it and it is hitting the gong, then it is separated from the screw. So the circuit remain open and it's lost its power of magnetism. But due to spring attached to it, again it is attaching with the screw, making the circuit complete. Again electricity flows to it. It's achieving the electromagnetism, attracting this, and this hammer is hitting the gong. Again due to spring it is getting back, again circuit is completed, it is attracted by it, the hammer hit the gong. So it will continue until and unless we are switching it off. That is how the electric bell works. So I will read it once again for you. What are the components of electric bell? The electric bell, figure 14.20 shows the circuit of an electric bell. It consists of a coil of wire wound around an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at the end kept close to the electromagnet. This is the iron strip, the hammer kept close to the electromagnet. There is a contact screw near the iron strip. A contact screw near the iron strip. When the iron strip is contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. Will the coil remain an electromagnet? When the current stops flowing, it will not remain an electromagnet. The coil is no longer electromagnet if no longer attracts the iron strip. The iron strip comes back to its original position, touch the contact screw again, complete the circuit again. The current flows in the coil and the hammer strikes the gong again. This process is repeated in the quick succession. The hammer strikes the gong every time the circuit is completed. This is how the bell rings. So this is the simple activity of electric bell. Simply we have taken piece of iron, wrap around the wire. Whenever electric current flowing through the circuit, it becomes electromagnet. It's attracting this iron armature and it's attracted towards the electromagnet. Hammer strikes the gong and the circuit disconnect. Due to spring attached with it, again it is getting back, attached with the screw, circuit completed. Again the same thing happens. So this will continue until and unless we are switching it off. This is how electromagnet used in electric bell. We have completed the chapter. Following are the keywords which already we have discussed about. Battery, more than cell connected to form a battery. Electric components, what are the components of electric circuit? How to draw the circuit diagram? How does an electric bell work? Electromagnet, fuse and its important, heating effect of electric current and magnetic effect of electric current. Hope you have understand the chapter well. Thank you.